welcome to today's webinar. Our webinar title today is Introducing Amazon Lex, Service for Building Voice or Text Chatbots. Our presenter today is Niranjan Hira, and today with us we also have Vikram, Harshal, and Victoria. They'll be the webinar moderators who will engage with you and answer any questions you have, so keep them coming. We love the engagement that we see already today, so keep any of those questions coming for us throughout the presentation. And again, welcome. Niranjan, the floor is now yours.
Thanks. I saw a screenshot with an ATM, a cash machine, that ended the session with, "Have a great day." You know that last screen when you're done? "Have a great day." That's what it said. And it got me thinking, why does the ATM care? It doesn't know any better. It probably doesn't care. Well, that's not the whole truth, perhaps. It doesn't really care, but the people who designed that software may have cared. And their expression, whether it was genuine or just customary, made it into the experience. So why does it matter? Why do some of the best user experiences use a consistent voice or persona to talk to their users? This might come as a surprise to some, but apparently we humans like interacting with other humans, or machines that appear to be human anyway. We find these interactions natural, and that can be reassuring. My name is Niranjan Hira, and over the next few minutes, I'd like to talk to you about how you can use Amazon Lex to have conversations with your users. So we should see how Amazon Lex supports some of these conversations, and more importantly, how you can use it to build applications and some of the things it does to make your lives as developers easier. We'll also have room at the end for questions, but keep them coming in the chat as we asked. So our interaction with machines has improved dramatically in the last few years. When I'm in the kitchen making my coffee, I routinely ask Alexa about the weather. I don't have to compile a program or push buttons or even use the same word each time. I just ask, with the confidence that Alexa will often understand me and answer the question. And why is that important? Because it's efficient. The less I have to think about what I'm asking for, the more I can think. Imagine if you could use your voice to truly analyze data. Plot the data, change the chart, flip the axes, exclude outliers, look for patterns. Would you go faster than you do with your mouse? Not only are we more comfortable with natural language, but we can be more productive with natural language. So what stops us? Well, it's a hard problem, right? We have to address the basics of speech recognition. People don't always speak the same way. People look away from the microphone. People don't always use the same words. People don't always use the same slang. And then there's the normal IT issues of scaling and availability and mobile access and platforms. So there are a number of technical problems that need to be addressed. But if we could address those problems, what we'd be able to do is to provide a consistent user experience, a conversation that appears natural to users, that is available on demand, whether it's right around the holiday season when you've got thousands of people calling in, or whether it's in the middle of the afternoon on an average Tuesday when there aren't that many people, and you'd only pay as you go, which is an essential aspect of cloud. So imagine using the same high-quality speech recognition and natural language understanding capabilities of Alexa, but for your applications. You can use Alexa today to build text and voice chatbots. Imagine doing that for your applications with your branding. So we start with the ability to recognize speech and parse it into the appropriate natural language components and determine what the intent is. In other words, what's the user actually trying to do? And then the ability to convert text that your applications provide back to speech. And that's a good aspect of it. But then there's the whole thing about, well, what bits do I need to know? So just as Alexa tries to prompt the user to get information that it determines slots, Lex will manage the dialogue as well. And remember that as human beings, we don't always speak with the same flow. You might start the conversation about ordering coffee, for example, by first talking about the size of beverage, And you might at another point talk about the type of beverage. And there's no reason why you should be forced to talk one way or the other. The whole point is the system should understand you. It's easy to deploy these. It's easy to scale them because we use AWS Lambda in the background. And then most importantly, you can have the same security as you integrate with both apps that are running on AWS, as well as applications that are accessible from AWS. Most importantly, you can turn around and then analyze the metrics that you see. So as an example, if you build a bot that listens to one form of slang, but hasn't figured out a different form of slang, what you can do is you can capture that information from the analytics and improve your bot as you go along. So the idea here is to use the brains of Alexa to make them available for your applications, but then to allow you to use them in many different ways. For text and speech language understanding, you've got the same automated speech recognition as Alexa and the same natural language understanding as Alexa. And what this really means is, as Alexa becomes smarter, your applications become smarter. You can deploy across different platforms. So you could choose to, for example, create a bot that's available on a mobile device, such as an iOS or an Android device. You could also make a chatbot that's only available on Slack, or then put it on Facebook Messenger. You could create just a web interface and incorporate Lex into your website, or you could make that part of an IoT experience. And to do all of this, you start with the simple Lex console. So the idea here again is to minimize the amount of code you need to write. For example, Lex remembers the context and can manage the flow of the conversation. All it takes is just a few minutes in this Lex console and you're ready to start testing your bot. And there's some great examples that you can start with. When you're done with that, you can use AWS Mobile Hub, and that allows you to get ready source. All you do is you download the sample source, and then you build the application, deploy it on your device of choice. Or what you can do is you can reuse the identity pools and some of the other information that's managed for you in the background to create a new web experience. So imagine being able to create a bot in 10 minutes or so. And when you're done with this, you go to AWS Mobile Hub and you say, I'd like to create a mobile project with it where I authenticate users, I synchronize data, I track retention, and I'd like to store and share media. You can do all of that and get a sample app in the next 5-10 minutes. Once you've got that application, you can start tweaking it to incorporate it into your code base. You can also use SaaS connectors just like you can with Mobile Hub. So as an example, you could build a bot that connects to Salesforce.com. You could build one that connects to an application of your choice that, for example, exposes an order status web interface. So imagine that you've got an Amazon Lex chatbot that a user can either speak to or type to. And it, for example, will tell the user when her order was shipped, or for example, when it might be available at home. The other thing, because Lex was built for developers, is to track versions and aliases. So remember that bots can sometimes grow with multiple intents, with multiple purposes. And as different teams work on them, you wouldn't really want to have just one bot running in production the whole time. What you'd like to be able to do is to say, hey, team A, why don't you take on the prod version, and team B can work on a new feature branch, while team C supports the version that's in production right now by adding intents to it as time goes on. We talk about missed utterances. So the idea here is to keep improving the bot on a regular basis by monitoring what's available in CloudWatch. So every time an utterance is detected or missed, you see an entry in CloudWatch. You see how often your users interact with Lex. And just as you might have peaks on a website, you might also have peaks in interactions with Amazon Lex. And that gives you some sense about how your users engage with Lex. More importantly, it allows you to create bots that can learn as they go. Missed utterances can easily be added right back into the bot to improve the bot. So what might you use Lex for? Well, you can use Lex to create informational bots that tell you things like the weather or scores. You can certainly use it to build enterprise productivity bots that, for example, can check the current sales quota. You could also use them to do things like book tickets or book flights or order food for you. So why should you use Amazon Lex? Well, remember that as a developer, you don't actually have to understand natural language processing. You don't have to learn about computational linguistics. You can simply start with one of the existing templates, think about the ways in which your users will interact with their bots, and mimic it. So that's all cool, but how do you actually build a bot? Whether it's to book a flight, order pizza, or make an appointment, each bot has a purpose. Lex uses the term intent to describe the actions or actions that a bot can perform for the user. And you can have multiple intents. So I could have a bot that, for example, starts with booking a flight and then switches over to trying to find a hotel. Each intent corresponds to utterances that represent phrases the user might speak or type. So I might start by saying, I'd like to book a hotel, or I might simply say, I'm going to New York. You don't have to get all of these down. Lex will understand more than just the phrases you provide. And remember, most importantly, the idea is to capture what's missed so that you can continue to improve your bot over time. You'll see that Lex also prompts to ask for information. So if you say that in order to book a flight, the two things you need to know are the dates and the city, you can make Lex ask for those in whatever order the user prefers. Because spontaneity in terms of natural conversations is critical. Lex will prompt for the information, and the responses are used to fill slots just like Alexa. So let's take a look at how this might work. Let's imagine that a user speaks to a mobile device and says, book a hotel in New York. That WAV file, that MP3, that LPCM, is then streamed over to Lex. Lex hears, using automatic speech recognition, text that is transcribed, and then it uses the model to get information about the type of intent. So in this case, we're trying to do a hotel booking, and the city. Now this is important because your model is overlaying what's part of Lex in terms of its background, in terms of what it gets from Alexa. So Lex inherits everything Alexa knows. Well, then on top of that, you can say, this intent is to book a hotel, and therefore when somebody talks about rooms, it's in the context of a hotel. That intent and slot model mapped to the utterances then allows us to get these slots filled out. So we see slots, for example, like city, the check-in date, and the checkout date. Lex can also prompt the user to say, hey, is it time to actually book? Are you comfortable with this? And then that interaction works with Lambda. When your code is done, your code can turn around, place the booking, and then say something like, your hotel is booked for November the 30th. Lex uses Amazon Polly behind the scenes to then speak that sentence back to the user in a voice that you choose. So here's an example of how Lex works through the conversation for you. The dialogue manager is smart enough to say it needs to know the city and the check-in date. And given that those are required slots, Lex can prompt to ask for what city. And what's important is that you can also say to Lex, use one of these prompts. And why might you do that? You'll do that because If Lex said the same thing every single time, that doesn't appear natural. It might be consistent, but it just is too robotic. So we encourage people to use multiple prompts and then allow Lex to randomly choose between those prompts to say, what city will you be traveling to, or where are you going? Once Lex has determined those slot values that need to be filled have been filled, it'll turn around and it'll provide that information to the Lambda so that the Lambda function can then do what it needs to. As an example, your Lambda function might turn around and prompt for more information, or you might simply return to confirm the information that you already know. One of the other things that's important is to know how Lex maintains context. Remember that just like with a web session, Lex allows you to track session attributes. And using these session attributes, you can share information between intents. In a dynamic conversation, such as one where you might start off with booking a flight and then switching to a car, or vice versa, it's important to know that Lex will allow you to keep the information within that voice session. So the dialogue manager makes it easy to build what we refer to sometimes as multi-turn conversations. And they're easy to set up in the console, because what you can do is you can start out with an intent, and that intent is shared at the account level, and you can create multiple versions of that intent, and then incorporate those intents into bots. You can also customize conversations. So imagine if on the phone you happen to know who this user was. You could use the Lambda to go find information about this user. In the IVR world, it's called a data dip. And you could use that information to personalize the information that you present. So knowing that this user is based out of San Francisco, for example, you might offer flights out of San Francisco when another city has not been mentioned. You can also use the Lambda function to validate user input and reprompt. So for example, let's say that the user talks about a flight to New York, and you just happen to know that New York's extremely busy over the next few days. You could actually have the bot be smart enough to turn around and say, well, what about flying into Baltimore and driving up? Lex also takes care of error handling for you. So what you can do is you can have Lex return with prompts that say, I don't really understand what was said, or could you please repeat that? And just like with the other prompts, what we really like to do is to use different prompts and have Lex choose at runtime. You can also have Lex end the conversation when it finally gives up to say, I'm sorry, I just can't help you. And that would be a great metric to track. As you create these experiences, remember that you can choose voice and you can use text, and you can deploy them across multiple platforms. Just as you can deploy natively with Twilio, Facebook, or Slackbot, you can also create web experiences using the Rich API to use rich text formatting or images. And then you can use these response cards to create web experiences that, depending on where the user is, will choose between multiple images at once or an image at a time. For fulfillment, Lex starts off with Lambda. Well, there's no reason, for example, you couldn't have the Lambda function turn around and call an API that's available on an API gateway of some sort. And for those of you who are familiar with this, you could, for example, use Direct Connect to make a different service that's available on-prem be visible into your AWS VPC, and then turn around and have your Lex function invoke that function that's actually running on-premise. So what does the workflow look like? Well, first you start off with some simple utterances. You create one or more intents. You save that model. You build your bot. Takes a couple of minutes sometimes because it's creating an application behind the scenes for you. Creates a REST API endpoint. You then publish this bot using an alias and a version. And then you're off to testing. Here's the cool thing. You can use the metrics to turn around and add utterances. If you see that consistently your bot is mixing an utterance up, you can disambiguate by adding something. So there's a model API, just like there's a runtime API. And you can script those model changes. And you can introduce them into lower environments, or you could even, for example, set it up with A/B testing. One of the important things to recognize is that because this is API driven, you can take the text that has been interpreted and pass that along to other services. So for example, if you wanted to support supervised experiences while you were training your Lex bots over time, you could. Lex also comes with a number of predefined resources. So many of the built-in slot types that are available with Amazon Alexa are also available for Lex. You can also define your own. And just as there are built-in slot types, there are also built-in intents. You can work with Facebook, Slack, or Twilio out of the box. But you could also add experiences for your websites and other applications that support a simple API. Here's some of the customers who have used Lex already and have great things to say about them. I'd encourage you to check their website. Lex does have a free tier. So in that first year when you sign up with an account, Amazon Lex customers can send up to 10,000 requests for free and 5,000 speech requests for free. And then after that, for each 1,000 text requests is just 75 cents, and each 1,000 speech request is $4. At that rate, with the scalability that Lex provides, it's relatively easy to test out a bot without exiting the free tier. In other words, if you're just using Lex to see if it works for your use case, it's relatively easy to start out and stay in the free tier. So what does that technology look like? Behind the scenes, remember that Amazon Lex is a managed service that's running serverless and it's working within the AWS ecosystem. So just as you can use the API to interact with Amazon Lex, and it can, behind the scenes, interact with Cognito or CloudWatch or Lambda, you can certainly change your Lambda functions to integrate with other AWS services. As an example, you could take data from Lex and push it to a Kinesis Firehose. We'll talk about the chatbot challenge in a minute, but keep that handy. So remember we said that Lex uses Polly to create voice interactions. Lex uses Amazon Polly. Polly is a service that creates lifelike speech from text. You can use Polly to voice in 47 different sounds, or better yet, 47 different voices, sorry. There are 24 languages that are supported today. And that's important because Polly supports more languages than Lex. So you can create text that is accentuated just the way you want it using SSML. As an example, if you'd like to have your bot use your company name and pronounce it a certain way, you can use speech synthesis markup language to talk about your company in just the way that you'd like it to. You can also use different voices to make the bots more interesting. So I'd encourage you to try out these services. Both Amazon Polly and Lex are available right from the console. And Polly, for one, is pretty easy to just copy and paste text into. And you can use it to entertain people at home if nothing else. So let's talk about what we'd really like you to do. It is a chatbot challenge. You can register for the chatbot challenge. You can create your own bot. And as you can see, there are prizes. So what does it take? It takes you signing up with your AWS account, using one of the blueprints that are available. So there's a blueprint that allows you to order flowers, and there's a blueprint that allows you to book an appointment. Once you start with those, you can then customize those blueprints and build your own bots. I'd love to see what you guys come up with.